Okay, this is the second portion of the operation and maintenance pre-certification test preparation. With the globe valves, we'll start up right from where we left. The globe valve is used for flow control. You can throttle it, and you can also, they're used in pressure regulating valves, this particular design. A butterfly valve, they also call them 90-degree valves because they're 90 degrees from full open to full close. They have higher resistance to flow because of the paddle. They operate quite easily, and they cost less than a gate valve. They're used for flow control and isolation. A ball or a plug valve is also considered a 90-degree valve because it's 90 degrees from full open to full closed. Ball valve here on the left, and then a plug valve on the right. A sluice gate, they have these in reservoirs. And then the one on the right is a sleeve valve. And so there's sluice gates and your sleeve valves. Your pressure regulating valves, you have pressure sustaining and pressure reducing, and they maintain either upstream or downstream pressures depending on the position of the pilot adjustment. They should be maintained periodically. Annually during low flows is when the system I did, we went in and checked into those in the wintertime during the lower flows. They also can help reduce water hammer. Pressure reducing valves, they are used in parallel to handle high and low flows. You can see there's a larger regulator, and then there's a bypass to the left of the larger regulator, and so they're used for high and low flows. An altitude valve is it's a good valve to regulate tank levels. They're set to open up when a tank gets down to a certain level, and then they open up, and then when it gets full, then it shuts off. So anyway, that's set. Those levels are set. This is a pump control valve, and they allow the pumps to be started and stopped against closed valves. It's the best method to control water hammer. If you look on top of this regulator, when the pump is energized, the water is bled off the top, and this slowly opens and it trips this switch here. And then so it's essentially a closed valve. And when this gets all the way open, then it trips that switch, and then when you shut it off, the pump continues to run, and this slowly gets water on top of the bonnet, and then it slowly drops down until it trips that switch, and that's what shuts the motor off. So essentially you're starting and stopping the pump against a closed valve. This is a check valve, and what they do is they keep the flow directional. This paddle, as the water hits this paddle, it moves up and the water passes through it. So when it shuts off, when the flow stops, it backs up, and this slams shut. You get more water hammer with these types of valves. The flow needs to be directional with the pump discharge lines, customer service lines, and water treatment. One of the things about these, if you start a pump up, you want to make sure that the fluctuating pressures in the line caused by a check valve level out before you start the pump back up because of the water hammer. On an air vac, that allows air in and out, and so you have your ball float here, and they should be placed at high points of the system to allow high points. If you have a sudden draw, you want those on at a high place so that air can get into the line and so that it doesn't collapse. They need to have a screen on them. It's a number 14 mesh screen. And in the wintertime, you ought to inspect those air vacs to make sure that they don't ice over, because if they ice over, they won't work. The relief valve outlet is about 12 inches above the ground. This is a line collapse in Folsom, and the city of Folsom. The pipe is the main transmission line supply for the city of Folsom, and you can see where either a lack of or a plugged air vac caused the collapse of this line. Water hammer occurs when the valve is closed quickly, such as in a check valve, or you can close a gate valve too quickly. The one thing that I was taught when I was an operator is that you can't close a valve too slowly, but you can close a valve too quickly. So make sure that when you close a valve, you do it very slow, and that the rapid pressures back and forth cause that water hammer, and it can cause a rupture in a line. Your system mapping should be accurate, and it should ensure that the operators can locate the valves when you have a mainline break or you need to shut something down. Now pH, that's an expression that refers to the basic or acidic conditions of the water system. It's measured from 0 to 14, and 7 is neutral. So below 7 is acidic or aggressive, and above 7 causes scaling on the pipes. The pH alkalinity test. This is a picture of a cutaway of a piece of pipe that has scaled. It's expressed as calcium carbonate, and chlorine also lowers the pH in the water system. It makes it more aggressive. So if you have that in the line, if you are adjusting for scaling in your line, you may need to adjust your chlorine use and increase it more so you get a good kill rate. Water hardness is caused mainly by salts of calcium and magnesium. You can see these two cutaways of pipe with the scaling on the inside. They cause formation of soap curds. They also show chemical instability of the water. And they scale, you'll get the scale in boilers and fixtures. If you have industrial processes, they can also affect industrial processes. They also have objectionable taste and odor in the water. The Langlier index measures the corrosiveness of the water. So the thing that you need to know is if it's got a minus in front of it, it's aggressive, it's acidic. And if it's above that, then you get scaling. And here's the levels where you get different levels of scaling and your corrosion in your lines. Corrosiveness is an electrochemical phenomenon. They measure it with the Langlier index. A positive number means it's deposited. Again, a negative number means it's corrosive. They use metal coupons to measure the corrosiveness of the water. Adjustments, you can accomplish that by adding chemicals to increase or decrease the depositing. Sequester the problem with the use of polyphosphates, and pH alkalinity adjustment with lime sequestering and chelation. The alkalinity is the measurement of the water's capacity to neutralize an acid, and that is on a line, that capacity to neutralize acid is known as alkalinity. Alkalinity is determined by titrating to an endpoint with a pH meter or the use of methyl orange test. They also use sulfuric acid to perform the test. It affects the coagulation process. Also, you can get scale buildup with insoluble calcium carbonate compounds. And it's expressed as parts per million in CaCO3, and it should be considered soft. To be considered soft, it should be between 0 and 50 parts per million. Head loss is your loss of flow across elbows and pipe. Roughness of the pipe is a consideration. If you see coefficient tests, if friction losses are increasing, the bursting strength of the pipe refers to the pipe's ability to withstand the internal forces. Head loss, friction head loss, is caused by valves and pipe roughness. Can also be caused by scaling, like in this picture. The head loss is in direct proportion to the increased velocity of the water flow. And there are different factors that can slow down the velocity of the water. Alkalinity, again, is expressed as calcium carbonate. Frictional head losses. That's the energy used up by the water movement. There's two conditions that affect head loss, and that's the roughness of the pipe and the velocity of the water. Two conditions that affect roughness are the age and condition of the pipe and the type of pipe materials. C factor indicates the smoothness of the pipe. So the higher the C value, the smoother the pipe, such as this. You've got concrete pipe that would have a lower C value than your PVC pipe. And it's used to calculate the measure of flow and the pipe diameter. The two most common types of plastic pipe are PVC, polyethylene or PE, and ABS piping. The PVC is least susceptible to corrosion, and the C value is reduced by tuberculation. The water head loss is affected by leaks, pressures, and the efficiency of the meter maintenance. Attention should be given to leak reduction and unauthorized use, such as people hooking onto your hydrants. Some systems have 10% is acceptable. Others, they don't worry about it until it gets 20%. You won't see that on the test. Customer calls. If you get a customer complaint, you should get the name and address of the person. You should ask them what the problem is. If it's taste, odor, discoloration, about what time was the problem noticed, how long has it been going on. Ask them if their neighbors are having the same problems, because you're trying to troubleshoot and make sure that it's not something that's in the home. You should also ask if they've talked to the health department or the Division of Drinking Water. And then you should ask them to take a sample in a clean glass so that it doesn't dissipate and go away by the time you get there to investigate it. So if they can take a sample at the time they're calling you, so that you can see what they were experiencing, that would be helpful when you're troubleshooting. Cross connections are determined by the degree of hazard. And a cross connection is a connection between a potable source and an unapproved source. There's two types of backflow. That's a back siphonage and a back pressure. The water user is responsible to keep contaminants out of the water. They flush out debris and trapped air in newly installed assemblies, and you should have an effective program to minimize the degradation of the water system. Your cross connections are responsible for most waterborne disease outbreaks. And that with, if you have secondary irrigation, a lot of people, there's a lot of problems with cross contamination from secondary irrigation systems. Devices and assemblies. An air gap is a physical break. It's the only acceptable form of backflow prevention when their water could come in contact with sewage. It's got to be a minimum of 1 inch or 2 times the diameter of the pipe. It's the safest method of backflow prevention. Again, if there's fecal matter in the water, that's the only acceptable form. If there's a possibility of fecal contamination. Double check assembly has 2 independent internally loaded check valves, 2 shutoff valves, and there's 4 test cocks. An RP, reduced pressure principal assembly, is for high hazards. It has 2 spring-loaded check valves and a relief valve, which is located right here. There's 4 test cocks and 2 shutoff valves. If you ever see one of these, if you see this dump port, it's usually that's your that's an RP. A pressure vacuum breaker has an internal check valve, an internal loaded air poppet, and 2 shutoff valves, and there's 2 test cocks to test it. They are not designed for back pressure. A cross connection with again with an atmospheric vacuum breaker. They're not designed to protect against back pressure. And prior to the installation of any backflow prevention assembly or device, the owner should be advised of the thermal expansion hazards. If you install any type of backflow device or assembly on a home where it turns it into a closed system, such as a dual check on a meter, that you could create a problem with their water heater, so they need to put a thermal expansion tank on those. Your wire-to-water efficiency is the combined efficiency of the pump and the motor together. This is the formula, the second bullet. And the wire-to-water efficiency is the amount of energy required to overcome the inefficiencies of the pump and motor. Electric motors. Upon startup, an electric motor will develop torque and to turn the pump shaft and the impeller, and that causes a draw on high amperage. Once the pump is up and running, the amperage drops once it's up to speed. If you had to change the rotation on an electric motor, you can you can switch two of the 3 leads on a 3-phase. Transformers are step down. They step down the voltage, and a circuit breaker helps protect the circuit from overloads. A digital multimeter, if it's talking about measuring ohms, you're talking about resistance. So it asks what an ohm meter measures. That is resistance. A voltmeter measures voltage, and an amp meter measures current. A tachometer would show the pump speed, and the setting should be set to the next highest level. So if you're testing, for example, 110, you want to move it up to around 200, move it up to the next highest level so you don't knock out your fuses in your meter. A lightning arrestor becomes a low resistance conductor to the ground. Generally, they're used to protect equipment from lightning strikes. If you get a direct hit, you're going to fry it anyway. So they're made to protect against surges and things like that. But if you have lightning hit near the vault where your where your equipment is, it'll probably burn it up. On your power sources, your primary sources are your power company. But when you lose power in an emergency, you have your auxiliary generators that are powered by natural gas or diesel fuel, and you may need those in the event of an emergency. So in this area, when we've had high wind and that when they've taken out power lines, they've used these generators to keep the system pressurized with their wells. On your meter sizing, you want to consider the pressure at the service connection. The highest fixture in the building that's going to be served should be a consideration. Any backflow prevention assembly or device is a consideration. A 5/8 inch meter should be tested every 5 to 10 years, and it should not have more than 20 psi head loss across it. 1 inch and smaller meters shouldn't exceed 15 pounds per square inch of head loss across them. Meter installation. A meter pit's located on public property. The meter pit's relatively safe from vehicle and snow removal because it's flush. Riser pipe should be 1 to 2 inches away from the meter box, and the use of a meter yoke. Use a jumper cable to protect it from electrical shock from piping in the home. Meter accuracy. Measure the water flow. Worn meters will cause the meter to under-register, which will give your customer pretty much free water, and so you want to make sure you test those periodically. There's a lot of unaccountable water loss to worn out meters, and over time it's going to cost you in revenue. This is the formula for meter accuracy at the bottom. Mag meters or maintenance calibration should include the flow at zero, flow rate. Compound meters, you can see it's a main meter and a smaller meter off to the side. They're for low to intermediate flows, and occasionally they use those for high flows. Positive displacement meter, this is a nutating disc, and you can see this is the measuring chamber down in here, and you can see the disc as that rotates, it turns the totalizer. This is an oscillating piston meter. It's also a displacement type meter, and the water flows into the chamber, and that causes that piston to move up and down, and then that's what turns the totalizer. There's a higher head loss across these in a nutating disc. This is a velocity meter. You can see the propeller on there as the water passes through it, turns a totalizer. Venturi meters, they use differential pressure between, there's a high and a low connection here, and you have a transducer that measures the differential pressure across those. There's no moving parts in them, and they're best for providing uninterrupted flow. Iron, and with your customer complaints, these are the types of stains that it can cause, this rust color. It can get on your laundry. And also the formation of iron bacteria causes the slick slimes on the pipe walls. It causes taste and odor problems. It also reacts with chlorine increasing the chlorine use. Chlorine being an oxidant, if there's iron in the water, it will react with it. You can remove it through aeration and flushing and polyphosphates. When it's mixed with manganese, it reacts with dissolved oxygen to form insoluble compounds. This is manganese. You can see it's more of a black color. And iron mixed with the manganese results to form dissolved oxygen, forming insoluble compounds, and it causes those black stains. Electrolysis is the decomposition of material from an electric current in the water that's produced by the movement of the water. They use cathodic protection where they have a sacrificial anode, and that will dissolve. Magnesium anodes help prevent galvanic corrosion, and the galvanic corrosion is caused by dissimilar metals coming in contact, connecting the two. They use metal coupons also to evaluate the weight loss. Here's some cathodic protection installed in reservoirs. You can see they drop the anodes down inside there, and that's what is made to corrode rather than the tank walls. Groundwater is water passing through porous soil. It's called percolation. Water-bearing geological formation is called an aquifer. Wells, a sanitary seal, helps prevent contamination from entering around the wellhead. The well casing and pipe placed inside to keep the wellhead open. Grout is a mixture of cement, water, and sand pumped between the casing, and the specific capacity is the well yield in gallons per minute per foot of drawdown. On well maintenance, the water needs to be pumped to waste until it clears up before you put it in line. Once you start a well up, it needs to clear up and make sure that it has a turbidimeter, or you're testing it with some type of something to check and make sure that it's cleared up before you put it in line. You want to keep accurate records. They show decreases in flows and pressures, and that ensures each piece of equipment receives proper attention and to prolong its life. It shows when the preventive maintenance or repairs were performed, and it reduces the liability to the operator and improves your customer service. What that does is it's keeping a record of your equipment, lets you know when it needs to be maintained, which it extends the life on your equipment. A work order program is the best way to track when the system maintenance is. So you should have something that pops up saying that it's time to service this particular motor. This is my contact information. If you have any questions, you're welcome to call me or email me, and I will do my best to help you prepare for the test. So thank you, and this concludes the operation and maintenance portion of this presentation.